Okay, so here in this video, we're gonna look at the types of solutions that we have, right? When we perform the reduced row echelon form. Okay, so the first thing is the way we talk about system of equations, we're going to introduce some vocabulary, right? So the first vocabulary here is consistent, right? So we're gonna say a system is consistent, right? When we're referring to system of equations, it is consistent if it has at least one solution. All right, and it inconsistent otherwise. All right, has one solution, has infinite solutions, that all falls into the idea of consistent. Has no solutions, then it is an inconsistent system. Okay, so now in terms of our reduced row echelon form, right? So the idea is that we want to have a augmented matrix that represents a system. We get that augmented matrix into reduced row echelon form. All right, which is I'm able to do with any augmented matrix, any matrix. All right, now from there, right, it is up to me to kind of analyze it and determine whether the system is consistent, inconsistent from my reduced row echelon form matrix. Right now, the reduced row echelon form matrix is unique, right, in the sense that, right, as you change the operations and you simplify the matrix, right, along the way, all of that, no matter which operations you perform, which row operations, then you're going to get the unique matrix. All right? Okay, so in our reduced row echelon form, I want to define the variable r. All right, so r is the number of non-zero rows. Right? Okay. So number of non-zero rows, and that's going to be the same as the number of leading ones. Right? Okay. All right. So that is going to be our variable r. Right? And now we're going to define two sets. Right? We're going to define the set of column indices for the pivot columns will be denoted by D. All right, so here we'll have D1, D2, D sub R. All right, so R is the number of non-zero columns. That's also going to be the name indices, same one of elements in this set D. All right, now the columns that are not pivots, right, those will be denoted as F, F1, F2, F of n minus R. Right, where n represents the number of, excuse me, the number of variables. Okay, all right. Okay then. So here, let's take a look at this here. All right. So here we have an augmented matrix that is in reduced row echelon form, right? Where here are my pivots, right? One, everything in the column is zeroed out, right? So here there's 3 pivot columns, so that means my R is 3. All right, and then that set D that I was referring to is referring to which column I am in, right? So this is column 1, column 5, and column 6. So my set D, so this is the index for the column, 5 and 6. Right, now my set F is going to be the other columns, right? Again, if they're not pivot columns, right, then they belong in the set F. And that is the columns 2, 3, 4, 7, and 8. All right. So we use this reduced row echelon form to build these sets D and F, and also so that we can, in fact, write the solution set from the augmented matrix, right? So here is where we want to define what makes a variable dependent versus independent. Right, and now that comes here from these sets D and F. All right, so if J is an element of D, right, then the variable xj is dependent, is a dependent variable. All right. And again, if a variable is not dependent, it is independent, right? A variable that is not dependent is independent or free. So we use those terms interchangeably when referring to variables. They're independent or a free variable, right? Hence, you can think of the D dependent, F free, right? So now let's go back here to our augmented matrix that is in reduced row echelon form. Okay, so we could see here again, think of the columns, those indices, they represent the coefficients of x1, x2, x3, x4, x5, x6, x7. Okay, all right. Okay, and then from here, all right. So what this is telling me here is all right, excuse me, I'm just looking for something here. Okay, all right, so we have here our reduced row echelon matrix, and here we have our dependent variables. This last column is the variable of constants, right? So our dependent variables are the variables x1, x5, x6. And we have our dependent variables to be 2, 3, 4, and 7, right? With that last column representing the, excuse me, the constant. X1, okay. So now in terms of writing the solution here, right, when we say dependent, right, we'll write them in terms of the free variables, right? So for instance, when I look at here, my pivot X6, the way I interpret that is X6 plus 7X7 is equal to 3. And I can solve for X6. That's 3 minus 7X7. All right, and then now here let's look at X5. All right, again, X5 plus 3X7 is equal to negative 7. So that means that X5 is equal to negative 7 plus 3X7. Oh, excuse me, minus. All right, and then lastly, our last dependent variable, we can write X1 right, minus 3X2 plus 6X4 minus 5X7 to be equal to 9. All right, or solving for X1, we get 9 plus 3X2 minus 6X4 plus 5X7. Okay, now you can see why we refer to them as dependent, right? They depend on the other variables in the system, the free ones, right? Whereas the free ones, we are, again, free to choose what value they are. All right, now in terms of the solution set, we write this using curly braces and we use a column vector, right? And we plug in here for X1, we got 9 plus 3X2 minus 6X4 plus 5X7, right? That is the value for X1. All right, for X2, right, that is free, so we just write it as X2. X3 is also free, so we write X3. Right, X4 also free, so that is X4. And then X5 we write as negative 7 minus 3X7. And then X6, oops, right, that one is not free. All right, it is dependent, and we write that as 3 minus 7X7. And then lastly, X7 is dependent, so we write it like that. And then here, such that our free variables, X2, X3, X7, excuse me, X2, X3, X4, and X7, those are just some real valued numbers, right? So element of the real numbers. Now our textbook says it's an element of C, the complex number system. So that is also not incorrect. Here we are mostly interested in our real valued solutions for the system, but the book does open it up for it being complex, but I'm not too worried about that in our particular class here. So if you write R or C, that would I take that just the same. Okay.